Hi, this is Vishwesh, and this is my shader assignment. I built two PBR-based shaders in Unreal Engine 5 using the Material Editor. So the two shaders are the water and the raindrop shader. So the water shader stimulates the transol realistic translucent water, and the raindrop shader stimulates the rain raindrop effect on the water. So let's go in and see how I build these shaders. So we'll start with the water shader. So this is the water shader material graph, and we can see this material is a surface domain material, so which is applied on the surfaces. And we have blend mode as translucent, so maintain the translucent nature of the water and be visible inside. And then we have lighting mode as surface translucent volume, so this enables us to see through the water. And coming to the material graph, we have the four main elements. The four elements are the base color, creating the fade effect, and the normal map texture and refraction. Now let's look at in them individually. So in the base color, we are setting up the base color for our water. So this is an AI generated texture used as the base color. And we also have the scene color to reflect the color which is underneath the water. And we are using a blend overlay to blend these both colors, and then using a lerp and passing it to the base color of the material. And then we have a fading effect. So this fading effect enables us to decrease or increase the change the intensity of color in the water. So we have this mask and depth effect. So this depth is, as we go deeper into the water, the effect of the material or the texture sample increases. So this controls the alpha of the loop, and then it is passed to the base color. And we have this roughness and opacity parameters of the water. These are manually tuned based on the visual effect produced by the material output. And then we have normal map textures. So this is an animated normal graph system which fakes the wavy movement of the water instead of adding all the different objects. So this enables us to get the wavy nature of the water and make it look realistic instead of having multiple assets in the scene. So here we have the texture coordinate. So this texture coordinate gives the UV elements of the texture surface, and then we have the speed elements. The speed elements are used to control the flow or the wavy nature of the water. And then we have the planners, and then we have the texture samples. So let's look at the flow now. So this texture coordinate gives the UV coordinates from 2D to 3D, and these are multiplied with a constant 1 and then passed to the coordinates of the panel. And we also have these two scalars. This is speed x, speed y, and this is speed x and speed y. We'll talk about it. And then we append these two vectors and give it a speed to the panel. The same way we append these two and give it as a speed to the panel too. We use this spanner to scroll around the water. So this is the tricky part where this spanner gives the wavy movement of water from one side to other side. We are using two panners here because we want the water to move in both the directions, not and just get the colliding wavy features, not just a singular movement such as a treadmill or something. And then these coordinates are passed to the UV textures in. So these are again the same AI generated texture. We have two instances of it. And then we have these add and multiply nodes. So this add node will combine the output of both the texture samples and it multiplies with a constant. So in this multiplication mask, before multiplying, we are using a mask of R and G, and to make sure that the blue is constant. So we multiply this RG values, and to apply this to normal, we need a three-dimensional normal. So we are again taking 1. So and then appending this 1 to B. So it keeps the blue always 1. So this makes the blue channel always 1, and then we append this to the normal map of the water material. So this gives the entire wavy nature of the water, keeping blue as constant and changing the R and G based on the speeds. So these speeds are tunable based. So based on the speed, we can see the rate at which water flows. And then we have this refraction subsystem. So this refraction subsystem drives the refraction of the material. So it generally gives, so refraction is the bend of light when it's passed through a certain material. So when it passes through light, we can see the disoriented properties of the object which is on top of this material. And we are using the same texture sample speed to influence the refraction. So we get the R and G mask from the texture sample or the normal, and then we add it as normal to the Fresnel effect. So this Fresnel effect gives a glowy nature at the edges of the water where it interacts with the solid substances. And then we have this constant refraction amount, and then again we perform a lerp and then give it to the refraction. So this water material consists mainly of 4 subsystems: the base color setup, the fading effect, the animated normal maps, and refraction. So on this output, we got the normal from the animated normal, and then we got the base colors, and we are setting roughness to 0 to make the smooth texture of the water, and we are using opacity 0.8, and we also have specular of 0.5 to have the natural reflective surface to the water. And now let's look at the raindrop material. So this is also a surface translucent material. So raindrops are also much similar to water. So we use similar kind of material here. And we also have the surface translucent volume, so we can see through the raindrops. And then coming to the subsystems in this raindrop material, we again have 6 or 7 subsystems here. So here is the base color and the raindrop effect. So this is the raindrop texture which is used from the tutorial. And then we are again using the text coordinate to get the 2D, 3D map of the texture, and we are multiplying it by 3. So to have a granular small water droplets instead of a single droplet covering the entire texture. And from this texture, we are extracting the R and G channels to generate the normals which are applied to the normal of the raindrop material. So before going there, we'll look at the masks which we are using. So we have animated drop mask and a static drop mask. So this static drop mask gives an effect of static water, which we can read as the droplets on the surface, and this animated drop mask gives the moving droplets. So these are like falling raindrops. This gives an effect of water dropped onto a surface. So we use the alpha from the texture, and then we increase the strength and then subtract. So this generally makes it from a scale of 0 to 1 instead a scale of -1 to 1. And then we multiply it with 1 to inverse it, and then we add an exponential and pass it to the combined mask. So the combined mask is the output of animated and static drop mask. So the animated drop mask gets time and then multiply it by 0.7, and then it takes the blue channel from the texture, and again it subtracts, So this multiplication and subtraction converts the ratio of 0 to 1 to minus 1 to 1. And then we have the output of the static droplet, which is saturated between minus 1 and 1. And then we get the fraction output from the time, and then we multiply it with the saturated output. So this gives a moving water. So this generally adds a movement to the static drop generated here, and it is again attached to the final mask. So now we have both the static and animated drop mask. We combine them together and then again multiply it with the direction control. So let's look at the direction control. So this direction control generally removes the X and Y component and just has the Z component for the material. So as it rain comes from the top or from the sky, we just need to have it on the top surface. We don't need to have it on the bottom surface. So this is kind of optimization thing. So we are using the blue channel, which is Z in Unreal. So we have this blue channel, extract the blue channel from the vertex normal, which gives us the Z axis, and then we saturate it between minus 1 and 1. And then we multiply it with 1 again, and we add it to the multiplier. So the final combined mask and this gives us the output of only one direction. So this gives the rain droplet effect only on the top side, which is the Z surface, Z axis. And then we use this output to multiply with the normal, which we extracted from R and G. And then as we know, the normal is a 3-axis or a 3 coordinate. We need all the 3 coordinates to plug it into the normal. We add with a scalar 1 and then we append it and then we plug it into the normal. And we also use this mask to have the roughness of the surface. So this gives kind of a dynamic roughness to the water droplets. So they are smooth when they fall and they just fade away. And then we have specular of 0. So this is the main raindrop material where we have specular of 0.5, which again gives the transparent nature of the water. And then we have an opacity of 0.5 and we have this normal and roughness plugin. So we don't have any base color, so it's white. So it generally, as it's a transparent, it usually takes the color on the color of the material which it is applied. So we combine these two material onto a playable scene here. And before going into play, we see that we have 7 subsystems here, and then we also have 5 subsystems to have 2 material effects. Now let's look at the play. So this is the playground, and we can see the little watery effect with a texture which is AI generated. If we start in and see, we can move around and we can see the little raindrop effect here. So as we move around, we can see the raindrops falling onto the water and we can see the slight wavy nature of the water. So this wavy nature is generated and controlled by the speeds, and it is coming from the water material, and this raindrop structure which we see on the game are coming from the raindrop material, and the texture which we see underneath a blue ancient kind of texture, it is generated by Gemini Nano Banana model. So to summarize, we have two different material interconnected with several subsystems, and we added both of the material onto the plane with to a plane mesh, and we are creating this animated fake animated kind of water and raindrops. Thank you.